Um, okay. So today is day three, and on day two, I mostly did my work off camera, and when I tried to join, like do the live stream, I was not feeling very good. So like there was no proper live stream for yesterday's challenge, but yeah, like today I'm back, and see, I'm thinking to go all out today and see how it will go because I want to see what will happen if I completely indulge. I think indulge is the right word. Indulge. Huh. If I completely indulge into work and let's see what will happen. But today, like there will be no phone, there will be nothing, just me, my laptop, and you, and we will see what will happen. I want to do more, but let's see how we can do that. Um, okay, so today's challenge is we have to redo the previous problems. We have to do today's challenge. Uh, that is this challenge. I have like written half of its code, but there is one more thing to figure out. It's a very easy problem to be honest. Not to be honest, but it is mentioned here that this is an easy problem, and we need to do this like main only like half of its part is done, half of its ideation is also done, but execution we need a certain data structure maybe or something like that. We need to figure that out. We can solve it in under 10 minutes or maybe 5 minutes. Okay, we'll solve this. We will redo the problem. We will off cam off camera I will do JavaScript lecture maybe. I don't know. Yeah, like we can do that. Um, we'll do the JavaScript lecturing there. Um, yeah, like we can do it on camera as well. We will just hide the screen and lower the volume. Um, okay. So today's task is complete this problem, then revise all the graph sections of the driver sheet that I have done already. And third problem will be redo the previous problems. Fourth will be like third and fourth can be like we can shift if we want. And fourth will be completing the JavaScript lecture. Okay, these are the four things that we need to do today. And yeah, that's all. Like if we do these four things, I think the day would be pretty good. And if still like during night we have time and we don't want to sleep, I don't want to sleep, then we can figure more things out at that time of the day. Yeah, let's go. Okay, so the this problem is really easy. Like we need to count the number of ones in which like there is no other one in that row and that column. Okay, So the main logic that I was thinking of, like there is a brute force that we just iterate over the whole matrix, and we will check for each one if there is any one or one in any row and column. But that's too slow, and so we can. So I think I thought of an separate and alternate solution that we can firstly count the number of ones, and we will store the indexes of that one. Okay, and now in this vector we need to just check, like if like the I should be unique in every pair. Okay, so like if I is in one pair, if I is one, there should be no one at place of I in any other pair. Okay, and similar thing we have to do for J. Okay, and now um yeah, I was thinking of how to do this, and I'm not I'm not able to think of any proper strategy for this, but we can do this. What we can do is, um, okay, so we have like 2, 1, 4, 1, 5, 2, 5, 3, 5, 4, 5, 6, 7, 8. Okay, if we have this certain example, what we will do, we will just move to first number. Like one thing we can do is we can like double iterate over this vector, but that's also very slow. We need to think of any something else can be used here. I was thinking of any hash map, but I don't remember anything particular about that. Hmm. 1, 1, 1, 2, 3, 4, 3, 5, 4, 5. So like if I copy, I will just remove all the ones. This both will be removed. 2, open 1, 4, 6. How? Hmm. How to do this? Hmm. I don't want to iterate over the vector again and again. I want to think of something else. Maybe can we use Q? No. Can we use set? No. I don't know. Maybe using a certain different way. Or mm, I think we can do it using hash map. We should be able to do with hash map. Um, okay, so I was thinking is, but I was thinking we will store the this ing in hash map. Okay, like with this as well. Like we will do m I plus plus, not m, but you can say a. A is one map and B is jth map. Okay, plus plus, and we will form two maps in order map comma int a b. Okay, we will have two maps. In this we will store the frequency of ing. Okay, and then we will just iterate over 0 less than n. Count as the number, right? We can just make it c I plus plus. Okay, and if a of v of 0, um what we have to do is v I comma j. I'm confused in this. Like this is 1 comma 1, this is 1 comma 2, this is 1 comma 3, right? Well, 0 comma 0, 1 comma 0 comma, हाँ ठीक है, 1 comma 1, 1 comma 2, 1 comma 3. But this is j increasing, right? So this will be 1 comma 1 and this will be 1 comma 2. Okay, so I will be I. Okay, so this will give us the first, this one. Okay, if this is not equal to 1, is not equal to 1, is equal to 1, and b of v of I 1 is equal to 1. That means both I and j are 1. We will do count plus plus. That means both I and j are occurring one time. We can do count plus plus. And otherwise we can just shift from there if it is not occurring one time. I think this is fine. I don't know. There might be some error. Okay, or not. I knew okay, this can be some. Where is the problem here? Do we need to do this? Should we make two vectors for each one of these? You can do that. This is not an optimized solution, but yeah, we can do that. It should work. Yeah. But I think optimization is lost in this. What the hell? It is optimized. Okay. One thing we need to see is how do we figure this out? How do we insert two numbers at one time? How to push back to the push back of ARM or vector and CPP. Make pair. Okay, ऐसे भी किया था. It was not working in both cases. We did this right. Let's see what we can do. Take this question by ourselves. Do it for them. Let's choose route below. Hmm. Okay, the first part is done. That we have solved this question. The second part is to just try everything. This is the sheet. No, this internet is too slow. Your internet. Hmm. We need to do these three problems. Oh, why it is taking so long? Okay, we need to revise these 10 stages, 10 parts, I guess. Okay, yeah. First one is introduction to graph. I don't think it's very tough to do. So yeah, internet is too slow. We'll do that after some time. Okay, we can see the solution here, right? Okay. Here it's the same, almost same. Not problems. The drivers, the strings, everyone did the same. I was different. Bad. Okay. We have to do this way. First one is this. Let me just go through it. Is it, why is it giving the code in Java? Okay, so like this is very easy. I know what is directed graph, what is undirected graph, how we can represent the graph in two forms, adjacent matrix adjacency matrix and adjacency list. Okay, okay, that's good. Second, graph representation in C++. This is the same. Yes, there is a plus code, I think. Yeah, we will just import, like, we just take the number of nodes and edges. We just take the values of this. So there is a between U and P. We will just mark them one. Rest will be similar to. There will be a similar thing in adjacency list. We'll just take this. We will make a vector, and for like the index will be denoting the node. We'll just do this. This is for directed graph, and this is for indirected graph. That was a big deal about that. Now we need to do this connected components. Where DFS, okay. I think we have opened this. Connected component DFS. Connected component DFS. We need this diversity technique. I don't think it's happening here. There are some errors. But we just need to do is copy this, insert here, like this, and we will do this. We should open the traversal technique. Okay, wait. I'll okay, I will do these two first. I don't know if there is an error in the website still for my internet is shitty. I think then can be both cases. इंग्लिश खत्म हो गई. Okay, so we will be doing this now. Mm, A connected component is a group of vertices in which every vertex can be reached from any other vertex in the same group. To count the number of connected components, we need to explore the graph so that each vertex is visited is visited exactly once and grouped into its component. We can do this using either PFS or DFS. Each time we start a new search from an unvisited vertex, we discover a new component, mark all the vertices in that component as visited. This ensures that we don't count the same component more than once. Use a visited array to track the vertices that have been visited. Build an adjacency list from the given edges for efficient traversal. For each vertex, if the vertex is not visited, perform DFS or DSS starting from it. This traversal will mark all vertices in the same component as visited. Increment the number of components from each traversal. Increment the number of components. Increment the number of components for each traversal. Once all the vertices are visited, return the number of connected components. We first made the adjacency list from the edge list. Then we make a mirror-listed array. Initialize the components number. We started with 0 to the vertex 3 to the last vertex. We are going to make a queue. We are using the DFS. We will make a queue. We will insert I in that. The first we mark it visited, and we will um, and now if find queue for neighbor, if not visited queue neighbor is the case. And each time we will have a non-visited. This will be more component and plus within set. we have completed the learning part. We know the graph, we know its representation in C++. We don't have to do this. We know connected component in driver technique. There will be BFS and DFS. From the connected component, we have revised the BFS code, and from the DFS part, we have revised the DFS code. Okay. So one thing we can do is we can again like rewrite the BFS and DFS code for one time to revise it, or we can shift it, or we can shift to this part. We have to complete this part today. Problems on BFS and DFS, and then we can move to JavaScript. And we have only 4 days left. We get these 4, and still will be remaining with these 2. Okay. Let's see how we can do that. Um, should we go with it's only 40 minutes and just need to solve all these problems. Then we'll go to the internet is too slow. These are so lame, bro. This is nice. Oh, everything's premium.